I'm watching the stand-up maths video. Immediately, I think I could build this in Max. It's a cool effect. Essentially what it does, well, there's two effects you see, obviously. The one on the left is just a simple threshold. If a pixel brightness is above a certain value, it's white. If it's below a certain value, it's black. On the right side, it's using noise to generate that threshold. So if the pixel is brighter than the equivalent noise value, then it's white. If it's less, if it's not as bright as the same position, it's black. And the effect with that is you get a much more contrast image. And if you sort of, squint your eyes a little, you see the image. It's pretty cool. So I thought, let's build it in Max. One, he's doing it in Python, so he has to do it in post, and that's boring and loser shit. A Max, you do everything live. So that's what we're gonna do today. It shows a few core components of jit.gl.pix, which is very cool. So it'll be a good tutorial to follow along to get some jit.gl basics and get some in the world of pixel processing or texture processing. So let's start from the top. We're working in video. You want to see what you're doing, obviously, and we can do that with a jit.world object. Jit.world encapsulates a lot of the complexities of working with GL contexts. Pretty much, we just need to write to this GL world, and for that, we need to give it a name. I'm going to call it dither, and we can call all of our other GL or we can tell all of our other GL objects to write to dither. So whatever's on those textures will render to the proper place. I'm going to give it a few arguments. I'm going to say @dim 1920 by 1080. That means the internal dimensions of the jit.world will be full HD. And then I'm going to say @enable1. So that way we don't need to activate it manually. It'll just be on by default. I'm going to say @erase color. Erase underscore color 0.0.0.1. This just will make the background of the jit.gl world black. It's at 1, that means it's fully opaque. And I'm going to give it @floating1. That means that window will be floating no matter what. I don't typically like floating 1 because if I click away from Max, if it is not the focused application, the window disappears. So if you're doing like live projection type stuff, then this window would disappear when you would click away. Also, you can't make it a real full screen. It just makes the image as big as the screen. It doesn't actually make it its own, make the menu bar disappear and stuff like that. It might work differently on Windows, but I don't care about Windows at all. Sorry to you Windows folks, but I'm sure there's reasons. Anyway, so here it is. There's my floating window. Here's my jit.world. So I'm going to pull in a video on your sidebar here. You have a bunch of sample audio and video stuff. Under here is video. I already looked it up. I'm going to pull in b-ball. So make sure the patch is unlocked and grab it and pull it in, and creates a playlist object that's going to output a matrix. I need to render this output into jit.world somehow. I'm going to do that with a jit.gl video plane, and I'm going to tell it to render to dither. So I'm going to plug that in. Last thing I want to do with this playlist object that bball.move is hosted in, I'm going to press M on my keyboard, M as in mother, and I'm going to give it volume 0. I'm going to plug that in, lock my patch, and then click on the volume 0. Some JIT objects do not obey MSP routing, audio routing, which exists in patch chords. If I were to just play this without giving the volume 0, it would have sound, which is infuriating. Why does it do that? I don't know. It's some holdover for something. I'm going to do a loop, so it just loops forever. Now when I'm press play, look at it. It's rendering in our jit.video plane. I'm going to make this bigger. So there's that. Now we want to process these pixels, right? We want to get to where we want to go. So I'm going to create a jit.gl.pix object. I'm going to hold shift on my keyboard and I'm going to pull it over to this patch cord here. And as I'm holding shift and bring it over a patch cord, this will pop up. And then if I let go of my mouse, it's going to slot that object in this signal path. So notice nothing changed in that. That's because jit.gl.pix by default, if you lock the patch and double click to open it, it is this. It's just a simple adder. What is jit.gl.pix? Jit.gl.pix lets you do shader processing in a Max-like environment, similar how in Gen you can write C++ code in a Max-like environment. What is shader code? Shader code is code executed on the GPU. It's far more efficient for video processing than using your CPU. So in Max, see we have this blue and this green patch cable. Blue is texture information. That means it's processing on your CPU. Green is matrix information. That's processing on your CPU. Working with your CPU is extremely inefficient. GPUs are purpose-made to process video information, so it is hundreds of times, if not thousands of times more efficient. So if you ever see this, you should scream in your head and say, this is all wrong. Because if you do a few operations, a few things with matrices, it's going to choke up, absolutely choke the hell out of your GPU. So now we have this. I'm going to get rid of the in2 for now. So right now it's just passing through in straight to out. What if I wanted to add a value to the texture information? What's going to happen? I'm going to add 0.5. Let's see what happens. The image gets a lot brighter. Why is that? What's coming out of in1 is the pixel is a vector representing each pixel, and it's processing every single pixel every frame. So what I'm doing with this 0.5 is I'm really saying I'm adding 0.5 to every single pixel, which just makes it brighter. How is pixel information handled in GL? Well, you may be familiar with like web dev or Photoshop, where they're working with values between 0 and 255. So your R, G, and B values, your red, green, and blue, is between 0 to 255. Let's zoom in on that. Is between 0 and 255. When working with shaders, those values are between 0 point to 1 point. So it is a floating point value between 0 and 1. So adding 0.5 adds, 50% white to every image, every pixel. Notice I said vector earlier. That means you're operating across 4 components of a vector. Red, green, blue, and alpha. Alpha is your transparency. 0 is completely transparent. 1 is opaque, and any value in between. What was happening in this guy, let's concentrate on this threshold first. In this case, any pixel above 28% gray, I guess, or has a white value of 28% or above is going to be white. Anything below is going to be fully black. How do we do that in Max or in jit.gl.pix specifically? So we need, first, this image is colored. We need to pull the brightness value of each pixel. How can we do that? Well, we can change color spaces. So by default, we're working in the RGB color space. There's an object called RGB2HSL, which converts from the RGB color space to the HSL colors. HSL stands for hue, saturation, and lumen. We care about that last vector, lumen. That is the brightness of the pixel. I spelled it wrong. RGB2HSL. I plug this in right here. Notice the colors get all weird because out1 is expecting RGB values. We're giving it HSL values. But what I really care about is that last value, L. If we were to just pull that out, we would get a black and white image. How can we do that? Well, there's an object called Swiz, which allows you to pull out a component of a vector. Swiz is 0 indexed. So your first component of the vector is 0, your second is 1, your third is 2. So since L is the third component of our vector, we need to pull out Swiz 2. I'm going to slot that in there. And now we get a nice, beautiful black and white image. And this is what we want to work with, right? Because we want to compare the brightness of the pixels. So what we need very simply is just a comparison operator. I'm going to say greater than or equal to. If it's greater than the threshold value, this is exactly what we want, right? If it's greater than a threshold value, a given threshold value, it's going to be white. If it's going to output a 1, which is going to be white. If it's below that given threshold value, it's going to output a 0, which is black. Let's actually make this 0.28, same as the video, 28%. I'm going to slot that in there. There we go. And now we get a nice, beautiful black and white image, just like this guy over here. I guess I should clarify that what is out1 expecting? Out1 is expecting a color value. jit.gl.pix, the way it works, it goes pixel by pixel. So it says pixel at position 0, 0. Process that. The output position at 0, 0 is going to be this color. And then it goes on to the next pixel. That's essentially how, and that happens every single frame, every single pixel, every single frame. So that's how it's handling this. So we can change this value, obviously. If I change it to 0.5, more of the image is black. If I change it to 0.1, more of the image is white. How do we make this variable? Because that's what's cool about Max. We can make things variable as opposed to working in Python, where you have to set parameters and then execute the code. You can do that via a param object. A param object within a jit.gl.pix or a jit.gen context allows you to address a variable from outside of the gen patch. So I'm going to call this thresh. I'm going to say the first argument of thresh is the default value. So I'm going to give it maybe 0.5. 0.5 will be the default value, and I'll plug this in here. Now this is outputting 0.5 into this comparison operator from outside of the jit.gl.pix context. I can create a message box, say thresh $1. $1 is a variable object or a variable indicator. It passes through whatever value you give it with by replacing this $1. So if I press F as in floating point on my keyboard, I create a floating point box, and then I can plug that in to thresh. And now from outside the gen patch, I can change my threshold to 0. If I lock the patch, I can change the threshold to 0.1. There we go. And the video updates. And we can make a variable. And you can do cool stuff like maybe attach this to a kick drum or MIDI node or something like that. So it changes with music or stuff like that. That's something you cannot do in Python. That is that's the power of Max right there. But we're not worrying about that right now. I'm going to keep all of this. Now let's work on the random noise stuff. So I'm just going to unplug from out1. Just move this stuff to the side here. We'll come back to it in a bit. So first we need to address how we're getting random noise in here. Well, we can do that by an input into. Back in Maxland, I can create an object called jit.noise. And this is going every time you send it a bang, it's going to generate a random value for every pixel. So first we have to give it a few arguments, plain count 4. So it's operating on RGBA. Type, I'm just going to give it float 32. Dimensions, let's give it just 10 by 10 for now. And now if I create a jit.p window, to generate a preview window of jit.noise. Notice we don't see anything right now. That's because we haven't actually told jit.noise to generate a new frame. If I press B as in button on my keyboard, a little GUI button pops up. I can plug that in, lock my patch, and then click on the button. And now it's going to generate a random value for all 100 of these pixels, this 10 by 10 array of pixels. So we want to make sure we're generating, we're working on the same dimensions. We want the noise to have the same amount of pixels as the input matrix. So what I'm going to do here is I'm just going to make a jit.matrix. And this jit.matrix just exists to get information from. This jit.matrix is going to adapt to this input, and then we're going to take advantage of this dump out. If we send jit.matrix a get state message, it is going to dump out a bunch of information. If I open up my Max console and then create a print object to print to console, connect the dump out outlet to here and click get state, it's going to give me a whole bunch of information about that matrix. What I care about is the dimensions. This is telling me how big that video is. It is 320 by 240. I want to send that every frame because say if I'm working with a bunch of different videos that's being received here, I want it to continually update. So I'm going to create what's called a trigger object. I'm going to create an object, trigger list bang. So what these patch cords are doing really is they're outputting what is called, it's just outputting a pointer to a matrix. So it's not copying the matrix from this position to this position. It's just saying, oh, look at this area in RAM and here's where that video exists. So it's saving on resources that way. So it's really just a list. So if I plug this in here like so, we can't see it, but you notice right here, it says JIT matrix and a string. It's sending that jitter matrix every frame to update this jit.matrix. Then I'm going to pass this bang into this get state. So what trigger list bang does, it every frame, first it outputs a bang, then it outputs a list. It goes from right to left. And this can be anything. It could be a symbol, it could be a number, it could be whatever you want it to be. But if you want particular order to an output, trigger is the way to do that. So I'm going to plug this in to here, and you notice my console is about to go wild and crazy. It's not updating. I think it's this. Yep, it's the same size, so it's not up. It doesn't look like it's updating. But I don't care about all this information. I just want the dimensions. So I'm going to use an object called route pass. Route pass is you can have a filter argument or a filter dim, and it's going to take whatever values that are after dim before the next word, essentially. So route pass dim, and it's also going to pass dim through whatever you have as the message. So I'm going to plug this in here, and now you're going to see dim 320 by 480. Perfect. So now, instead of putting that into my console, I'm going to put it into jit.noise. And now, when I update jit.noise, it's a lot more pixels. It's 320 by 240 pixels. So obviously it's not updating any frame. If we wanted to update every frame, I'm going to use another trigger list or trigger bang list. So first it's going to output that list. So now that it's banging every frame, it's updating every frame. We're getting new values. That's why you get this noise. And then I'm going to pass along the list to make sure it stays up to date with the dimensions of this input matrix over here. I'm going to press Command Y to make that pretty. So now we have a random noise generator. jit.gl.pix, because this is GL object, is working in textures. Your first inlet of jit.gl.pix can be a matrix input. It can convert from a matrix to a texture, but only for the first inlet. Every other input you use, it needs to be a texture, or else it won't work. So I'm going to convert this jit.noise using a jit.gl texture to convert the matrix, the output matrix from this jit.noise into a texture. And then I'm going to pass it along into this jit.gl.pix. Now, if I go back to my jit.gl.pix, here it is. If I actually just pass along this into my out, it's going to output that noise directly to the output. But we don't want to do that. We want to do a similar process as before. So I'm actually going to take the output of this RGB to HSL. Let's bring that back. But I need to do the same process for this in too. for the noise. So I'm going to create another RGB to HSL, and then I'm going to pass that along here. Now, and also I need the swizz for both of them. I'm going to bring both of these back. Swizz. Instead of a constant being outputted into this conditional operator, like before, it's going to be a variable, and that variable is going to pull from this swizz2, like so. So I'm going to plug it in like this, and then plug it in, and there we go. We got that stand-up maths effect, but happening live with an input. And you can, have pre-recorded video in here. You can have live video from a camera in here as well. So a lot of flexibility with this, and that's the power of Max, folks, and that's why we love it. I want to go a step further. I want to really mog, as the kids say, a stand-up maths here, because not only did he do both of these effects in post in Python, but then he used video software to get the half and half effect, right? I want to do it all inside of Max, because Max is just that cool. So how do we do that? Well, we want the left side of the screen to be the threshold. We want the right side of the screen to be the random noise. So we need the pixel position, right? Every pixel to the left of a given pixel will be this input. Any pixel to the right will be this input. So we need to figure out what pixel is what, the position of the pixel. And we can do that through two objects, norm and snorm. So similar to the value of the pixels, how they're between 0 and 1, in gl.pix, the pixel position is normalized between 0 and 1. So to the left, that is your x position 0, and all the way to the right is your x position 1. It's not the actual, 1920 by 1080 or whatever. It is 0 to 1 always, no matter the size of the matrix or the texture. And same thing is true from your x to y. 0 is your y, 0y is right here, and 1y is at the bottom of your screen. So we need to take one of these. Norm is your normalized components, your normalized pixel position. So that's 0 to 1 as before. But snorm is signed normalized. So that's taking from the center. 0, 0 is the center of your matrix or your texture. And to the right of that is XY positive. To the left or to the right of that is X positive. Below is Y negative. Above is Y positive. So this is two ways of working with textures. What I'm going to do is I'm going to use my signed normalized components. So I'm going to say if the X value is greater than or equal to 0, then it's going to be this input. If it's less than 0, then it's going to be this input instead. So similar to before, we need to use swizz to pull the X component, because that's what we care about. SquizX, both with RGB and coordinate positions, you can name the variable, you can name the component. Swizz is smart enough to do that. I'm going to say if the X coordinate is greater than or equal to 0. So I'm going to pull that. So here's our comparison. If it's greater than 0, it's going to be a 1. If it's less than 0, it's going to be a 0. So I'm going to say switch. I'm going to use a switch operator. And my first input of switch is my condition to test. So that's going to be my comparison operator here. And then my second input is value of true. So value if it is greater than 1. So we're going to take my greater than or equal to. I'm going to plug that into if true, because this is going to appear on the right side. And I'm going to take this guy, put in here. This is going to, whatever my input in here is going to be my value if it's less than 0. And then I'm going to plug this into out. There we go. And we get the side to side. Isn't that cool? Just like this, but we're doing it live, processed with live video, with anything we want. Isn't Max so cool? We love Max. Okay, That's awesome. But let's take it a step further. That's what I always like to say with Max. How can I take it that extra step that only Max lets us do? We're going to do that with the greater than or equal to 0. Instead of having it be a fixed point, I'm going to say make it a variable that we can address inside of the max patch. So similar to param thresh, let me do this actually. Param, I'm going to call it param cross. And I'm going to make it default 0. Instead of it plugging it into here, you can you can call the param directly within an operator. So I'm going to say param cross. Nothing changed because the default is 0, but I'm going to have to go out back into the main patch. And then I'm going to copy and paste this and rename this to cross. And then plug that into the jit.gl.pix. And now I can change where the crossover is. Is it going to be if it's less than 0 or if it's greater than 0, it's going to change that position. Isn't that cool? We can make it up and down too. If I, instead of using Swiss Y, or Swiss X, I'm going to use Swiss Y. And now, just like that, it's up and down. And look, the cross works exactly the same. Isn't that so cool, folks? And fairly simple to understand too. So Max is super powerful, gives you a ton of flexibility, and lets you work live within your code, as opposed to typing stuff, exporting it, and then seeing if it works. You can experiment live inside of Max. I hope this gave you a good understanding of how jit.gl.pix works. Some very simple basics with jit.gl.pix, but I hope that gets you on the right footing to explore this very powerful application. If you want to download the patch, it'll be below. Thank you so much for watching.